just need to show one counter example. So I'm going to start by letting theta equal 0 degrees. So let me write down the cosine of 2 theta is the same as theta plus theta. And I want to prove that it's not equal to this. Okay, so theta plus theta, and we're coming back over here, and I'm going to use this exact same concept, theta plus theta. I'm writing this down with a subtraction, knowing that my alpha and my beta will both be thetas. So this is equivalent to the cosine of theta times the cosine of theta minus the sine of theta and the sine of theta. Now, what is theta for this problem? Oops, sorry. I meant to move this over. What is theta for this problem? It's 0 degrees. So the cosine of 0 degrees times the cosine of 0 degrees minus the sine of 0 degrees times the sine of 0 degrees. So let's go to 0 degrees. It's right here. At this position, at 0 degrees, we have an ordered pair of 1, 0. So the cosine of 0 degrees is 1. 1 times 1 in this range is 1. Now let's do the back side of this problem. So the sine at 0 degrees is 0, and 0 times 0 is 0. 1 minus 0 is 1. On the left-hand side, I have 1. Let's see if this works as a counterexample. All we need is one counterexample in order to verify that it's not an identity. So if we do 2 times the cosine again, and here we're using theta is equal to 0 degrees. What is the cosine at 0? It is 1, and 1 times 2 is 2. 1 is not equal to 2. I was able to verify that this is not an identity. Let's look at the next one. All right, so here I'm going to call upon this particular formula, and I'm going to choose 2 common angles. So we're talking about like 30, 45, 60 angles that I already have memorized what the sine and cosine of those common angles are. So let's come back here and let's make this, and again, my goal is to verify that it is not, identity. So let's make theta equal to 30 degrees, and let's make beta equal to another common one. Let's try 60 degrees. Memorize those, I already know what those are. So I can come on the unit circle here. I have 30 degrees and 60, so this is 1, 2, 3, 1, 2, 3. So I have my cosine and sine, and my cosine and sine both for 30 degrees and for 60 degrees. All right, let's get started. So what is this equal to? I want to prove it's not equal to this. So I'm going to write down right now sine of 30 degrees, cosine of 60, plus cosine of 30, sine of 60. So I have the sine of my first one, sine of 30 degrees, times the cosine of 60 degrees, plus the cosine of 30 degrees, times the sine of 60 degrees. All right, let's plug this in now. What is the sine of 30? The sine of 30 is 1/2 times the cosine of 60, which is 1/2, plus the cosine of 30, radical 3 over 2, times the sine of 60, radical 3 over 2. So I have 1 over 4, 1/4, plus radical 3 times radical 3 is 3 times 3, that's 9 over 4. So I have 1/4 plus, well, the square root of 9 is actually 3 over 4. Now when we have the exact same denominators, we get to add the top, so 1 plus 3 is 4, keeping the common denominator, and I have an answer of 1 on the left-hand side. Now let's check if I plug this in. Is 1 equivalent to this? So what is the sine of theta, the sine of 30 degrees? So is this equal to the sine of 30? The sine of 30 is 1/2 plus the sine of b. Well, my b is 60. The sine of b is radical 3 over 2. If I was going to add these, I have 1 plus the square root of 3, keeping the common denominator. These are not the same. I was able to show a counterexample proving that this is not an identity.